What are the 7 different forms of energy? Mechanical energy is the energy associated with the motion and position of an object. This is also the energy of machines. When things are moving, they have mechanical energy. And mechanical energy can actually be either kinetic or potential. We've seen elastic potential energy and gravitational potential energy. Those are forms of mechanical energy, but it's stored. We can have kinetic energy, which is the moving parts. When things are moving, they have kinetic energy. In this case, if these gears in this clock were moving, that would be kinetic mechanical energy. This windmill, when the wind blows and it starts grinding grain, that will have mechanical energy as well. It's the energy of moving parts. Cars, when they're driving and they're moving, right, that is mechanical energy. Thermal energy is the energy of all the particles in an object. And the faster the object's particles are moving, the more thermal energy that it has. So if something's warm, it's emitting heat, it's going to have thermal energy. The particles are going to be moving very fast. And when those particles are moving, it has heat, it has thermal energy. So we have fire, we have our furnaces producing heat. We have a chemical reaction that might produce heat. That is thermal energy. Chemical energy, this is a form of potential energy, and it's energy that's stored in compounds using chemical bonds. And we can find this in wood. We burn it, right? We can change that chemical energy into something else. It's stored. Bread, our body breaks down food and uses that energy. And propane, and that's stored, so maybe we can cook with it. Batteries can also store chemical energy. So chemical energy is very important, and it's a form of potential energy. It's stored. Electrical energy is the flow of electrons, and electricity runs all of our electrical devices like radios, lights, and computers. And this is flowing electrons. So when we have flowing electrons, moving electrons, we have that electrical energy, and it's used to do other things, and it's very often converted into different forms of energy. Electromagnetic energy, also called radiant or light energy, and this is the energy that we can see. The electromagnetic energy is all the visible light and the invisible light that we can't see. And we have a whole spectrum called the electromagnetic spectrum that light makes up. And this electromagnetic spectrum is what we're going to be studying later to get to know more about light. Nuclear energy is a type of potential energy stored in the nucleus of an atom. And energy is released when an atom splits, fission, or joins together, fusion. And in nuclear power plants, they use a fission reaction to produce electricity. So we can get nuclear energy changing into electrical energy. And here is a diagram of a fission reaction taking place. Sound energy is also called vibrational energy. And this is a type of kinetic energy, which is also a variant on mechanical energy, but it's often spoken about separately because it is so important to what we do when we use sound and vibrations in everyday life, from making music and using software to edit sounds and audio, and looking at the acoustics of rooms. So it's very important to study sound energy and vibrational energy. And this is the vibrations and the sound and the energy associated with it. Now, as I've talked about earlier, when we had nuclear energy changing into electrical, energy doesn't stay the same. It's converted from one form to another. And any form of energy can be changed into any other form of energy. So let's look at these examples here. We have a toaster. What do you think the energy change is there? Well, you plug it in, and so that's going to start off with electrical energy. And We're going to use that electrical energy to cook our toast, so that's going to change to heat or thermal energy. Now how about a car? Right? We have to put fuel into a car, and that fuel that we put into a car is chemical energy. And that chemical energy, when we run the car, is eventually changed into mechanical energy. Now when we have these energy conversions from one form to another, it transforms from one type of energy into another type of energy, we're always going to have energy conserved. And this is called the law of conservation of energy. This means that we're always going to have the same amount of energy before the transformation as we have after. So it's always going to be the same before and after. You might not notice this sometimes because you don't get as much out at the end, because always some of that energy is going to be changed into heat energy. Friction is a main culprit. Friction will always tend to cause heat energy to be wasted when we convert one kind into another. Old light bulbs are a great example of this, where a lot of the light, when it was made, right, wasn't actually, the electricity wasn't turned into light, it was turned into heat. So those bulbs got really hot, and that electricity was wasted in the form of heat instead of being just used as light. And the new bulbs transfer a lot more of that energy, that electrical energy, into light than heat.